Assalamualaikum and hi to everyone. Thanks for watching this video. Please share, like, and subscribe. So in this video, we'll discuss about the simple parity check. Okay, parity check is divided into two parts. We have the odd parity check and we also have the even parity check. So let's look at the simple parity check for odd. Okay, you need to know the basic concept of how this parity check works. Okay, for example here, we have data 10110101. This 1 we call as the parity bits. Okay, the red number in red is the original data that we want to send. And then this one is the parity bit data. So in odd parity check, we need to ensure that when we total up everything, it's become an odd numbers. So this is your data. We have 1, 1, 1, 1, 4. When we use the odd data, so 1, 1 plus 1 plus 1 plus 1 equal to 4. When we use the odd parity check, okay, we have 4. In order to make it odd number, so we need to add another 1 bit of 1. So we add 1 here. So now the total up is 5. For the even parity check, okay, let's say this is your data. We have 101010. This is your original data. We want to use the even parity check. So what extra bit that we need to add? So you can add everything. 1 plus 1 plus 1 plus 1 equal to 4. So we want to use the even parity check. So the extra bit here is 0. So when you total up, it's equal to 4. So it is even number. Okay. So when you receive a data, you can check either your number is even or your number is an odd numbers. Okay. Okay, the next one, we go for the two-dimensional parity check. Basically, in order to use two-dimensional parity check, you should know and should be master in the simple, odd, and even parity check. So look at this first example. Okay, example 1. Okay, for example, we have 5 packets of data need to be transmitted. You want to transmit those 5 packets of data. So each packet contains 7 of bits. So 1, 2, 3, 4, 5, 6, 7. So 7 bit, 7 bit, 7 bit, 7 bit, 7 bit. So we have total 5 of packets. Okay, now apply the even parity on those packets. So for packet 1, we want to apply the even parity check. So we add parity bit in every packet to make it even. So 1 plus 1 plus 1 equal to 3. 3 is odd number, so we add 1 as the extra bit or parity bit 1. So do the same things in those another 4 packets and you will get this parity check. So now you already add parity bits for each of the packet to make it even numbers. So 1 plus 1 plus 1, 3. 3 plus 1 equal to 4. 4 is even. 1 plus 1 plus 1 plus 1 is 4. 4 plus 0 is equal to 4. Even number. 1 plus 1 plus 1, 3. 3 plus 1 equal to 4. Even number. And then 1 plus 1 plus 1 plus 1 plus 1 equal to 5. 5 is odd, so we add extra bit equal to 1. So equal to 6. Now 6 is even numbers. And for this part, 1 plus 1 plus 1 plus 1 equal to 4. So the extra bit is 0. So now you have a set of data with the extra parity bits. Okay, next, add the parity byte for the packet based on the column. Here we have based on the row, now based on the column. So for this example, okay, we have 1 plus 1 equal to 2, so 2 is even number, so we just add 0. Do the same thing for the rest. Then at the end you will get 1 0 0 0 1 1 0. So this based on the column, is based on row. Okay, the next part, add the parity bit in this parity packet. So you have the packet of data, and now you have the parity packets. Parity bits. Parity packets lah. So we have 1 plus 1 plus 1 equal to 3. 3 plus 1 equal to 4. The number 1 plus 1 plus 1 equal to 3. 3 plus 1 equal to 4. So we add 1 as the parity bit at here. So now you have the original data with the parity packet. So continue from the previous one. For 1 bit error, okay, when you transmit all the 5 packets, and for 1 bit error, before this bit is 1, so now it changed to 0 bits. We change the data to 0, so we can detect there is an error here. So we can do checking. The total is 3 after you add the parity bit. So 3 is not the even number. So we can identify, or we able to detect that there is an error have occurred at this packet of data. So this is how we do check on the data that we have transmitted when it arrives at the receiver side. Okay, how about for 2-bit error? So now use the same data. Previous data is 1, so we change to 0. Previous data is 0, we change to 1. And then we do calculate. When we do calculate, 1 plus 1 plus 1, 3. 3 plus 1, 4. So this is even number. Even number. So, and then we also check for the column side. So 1 plus 1 plus 1 equal to 3. 3 plus 0 is not an even number. There is an error at here. Do checking again. 1 plus 1 plus 0 equal to 2. 2 plus 1 equal to 3. 3 plus 0 is not equal to even number. So there is an error here. So now, using the two-dimensional error, you're able to detect until 2-bit errors using the column as well as the row. You cannot depend on the row itself. So that's mean for the simple parity bits, we only able to detect for up to 1-bit error. Into this two-dimensional parity check, we can now check until 2-bit of error. How about 3-bit of errors? So now we try for 3-bit of errors. Okay, we change here, we change another here. Can we detect an error? So we try again. Okay, we do for row first. 1 plus 1 plus 1, 3, 3 plus 1 even. Then we check for the column part. So 1 plus 1 plus 1, 3. So this an error at here. Okay, how about this one? 1 plus 1 plus 0 plus 0 to 2. Okay, this one is okay. How about this one? 1 plus 1, 2, 2 plus 1, 3, 3 plus 1, 4. 4 plus 1 equal to 5. 5 is the odd number. So we can detect there is an error occur at this value and this value. So 3 bits error still can be detected if we use this two-dimensional parity check. If you can't detect it by row, you can detect it using the column. How about 4-bit errors? Okay, now we try to change another bit, this bit. So when do checking, the total is 4 after you apply the parity bits at this point, and do checking at this point, the total is 2 after you add the parity bit. You can't detect the changes. So you can make a conclusion here. After you check here, and then you check here, and then you check here, you can make a conclusion that 4-bit error can be detected using the two-dimensional parity. So either you use row or use the column, it can be detected. So the two-dimensional parity check only able to detect from 1 up to 3 bit of error. So hopefully you're able to understand how the process of parity check. Odd and even number is up to you. Either you want to use the even parity check or you want to use the odd parity check. For the simple parity check, you only can detect one bit of errors. For two-dimensional parity check, you can detect up to 3 bits of error, either by row or by column. So that's all for the two-dimensional parity checks. So see you in the next video. Thank you and Assalamualaikum.